Good morning, my dear friends. Welcome to online classes from MGBC Arts, Commerce and Science College, Muddebihar. So it's Department of Chemistry and myself, Professor UMARFAROOQ HALYAL. I am today going to take for your BSc V Sem paper 2. The unit is Industrial Chemistry. So as you know, from the same unit we discussed the two topics, that is alloys and abrasives, and today we are going to discussing about the new bit of this same unit, that is glass. So already we know, we touched the different types of glass materials, either in our home, in our laboratory, in our cars, buses, etc. For example, in our home we have to use the drinking vessels glass, or our windows glass, and our car glass, our car light glass, etc. So this topic glass has their definition, their preparation and composition of this different types of chemicals and variety of different classes and uses we have to study in this topic. Now coming for glass. So glass is an amorphous, hard, brittle, transparent or translucent supercooled liquid of infinite viscosity having no definite melting point. This is obtained by a fusing mixture of a number of metallic silicates or borates of sodium, potassium, calcium and lead. Here glass is nothing but it is a amorphous substance, and that is hard, brittle, transparent and translucent substance, and this is doesn't having a particular definite melting point, and it possesses no definite formula or crystalline structure. So this glass doesn't have any particular crystalline structure. Whatever we have give the shapes, that is going to have it. It is an inorganic product of fusion which has cooled to a rigid condition without crystallizing, and this glass does not have any specific melting point, softens over a temperature range, means in a particular temperature range this glass going to softens or going to soft. For example, in our laboratories we are using glass rods or capillary tubes. You already studied in your third sem small capillary tubes. Okay. So that capillary tubes, when we are going to heat, they are going to start it soften. When we are to bend it, they have to bending, or else the glass rods, when we are heating a particular temperature, they are going to soft. Now moving for the properties of glass. So in the properties, glass is an amorphous substance, this is brittle substance, transparent or translucent, and this is good electrical insulator, and this glass is unaffected by air, water, acid or any chemical reagents except hydrogen fluoride. Means this glass is unaffected air, water and acids, but only one acid is there or one chemical is there, that is hydrogen fluoride, that is going to affect for these glasses. And next one, So this glass does not having a definite crystal structure, means glass has high compressive strength and it can absorb, transmit and reflect light. In your physics, you studied regarding to the transmit and reflect of light. When you are passing a beam of light to the glass, on time they are going to reflect the light. Now, raw materials used in manufacturing glass. The first, sodium as sodium carbonate. These are using in soft glasses. Potassium as potassium carbonate, used in the preparation of hard glass. Calcium as limestone, chalk and lime. Lead as lithrase, red lead, that is manufacturing of flint glass. Silica or quartz, white sand and ignited flint. Here zinc we are using as zinc oxide for the manufacturing of the glass like heat and shock proof. Borates are borax, boric acid. These are using for heat and shock proof glass, means in our laboratories we are using borosilicate glasses. When we are using heating, they are not giving any types of maximum heat feeling to us. Then cullets or pieces of broken glass to increase fusibility. Here cullet means that is the waste glass pieces. And you saw the pie diagram in this corner of the screen, that is typical glass container composition. 72% containing silica, 13% sodium oxide, 12% calcium oxide, but that is means lime, 2% aluminium oxide and 1% different chemical minerals we are going to add for the manufacturing of glass. Now glass components, formants, that is network formation, we have SiO2, B2O3, different types of glasses. Fluxes we have to use for as the softeners. We have different types, means sodium oxide, potassium oxide, lithium oxide, aluminium oxide, boron trioxide, cesium oxide, etc. And some stabilizers, like they provide chemical resistance. The chemicals like calcium oxide, magnesium oxide, aluminium oxide, etc. And you have to see the diagram, chemical composition of glass. That is silicon 70 to 74%, sodium oxide 12 to 16%, calcium oxide 5 to 11%, magnesium oxide 1 to 3%, aluminium oxide 1 to 3%, and others 1%. That is the chemical composition of glass. Now manufacturing steps. So this manufacturing steps containing mainly 4 types: melting, forming and shaping, annealing and finishing. See the diagram. So this diagram shows the manufacturing of flint glass. First, we are going to use the raw materials. See the pictures. In the raw materials, we are going to use different chemicals and different minerals. We are going to mixing it. Then we are adding cullets. Cullets means that as the waste glass pieces. After they both adding, when we mix it, then we have to go to melting. After melting higher temperature, we are going to forming it. After forming, we are going to annealing. Then in the after process annealing, it is going to cutting for different shapes. After cutting the different shapes, they have to send it for inspection. Why? Because of only the manufactured glass quality is good or bad. For that reason, they have to send for inspection. After that, packaging. Here packaging has a very much important role in the glass. Suppose we package in unsafety manner, they are going to chance of break of the glasses. After that, delivery. Wherever we have to send these glasses, we have to send it. So this is the manufacturing steps. In the melting process, raw materials in proper proportions are mixed with cullets. It is finely powdered and intimate mixture called batch is fused in furnace at high temperature of about 1800 degrees Celsius. This charge melts and fuses into viscous fluid. First, we have to going to add in the proper scale all the raw materials. Then we are adding cullets. After that, we are going to heat at the higher temperature into that furnace. The calcium carbonate and silica is going to mix, and the formation of calcium, silica oxide and carbon dioxide. Again, sodium carbonate is combining with silica, that gives us sodium silica plus carbon dioxide. After removal of carbon dioxide, it decolorizes like MnO2, that is magnesium oxide, are added to remove traces of ferrous compounds, and carbon heating is continued till clear molten mass is free from bubbles and is obtained, and then we are going to heat for some certain temperature, then cool to about 800 degrees Celsius. The next one, forming and shaping. In this step, the viscous mass obtained from melting is poured into molds to get different types of articles of desired shape by either blowing or pressing between the rollers. In this step, whatever the mass obtained from the previous step, that is melting step, we have to pour into molds. Then we are going to this one for different shapes between the rollers. Next step is annealing. So whatever the glass materials coming from the previous step, that articles are then allowed to cool gradually at room temperature by passing through different chambers with descending temperatures. This reduces internal strain in the glass. In the annealing step, the mainly thing occurs, that is cooling of the different glass articles by sending different chambers to reduce the internal strain of the glass. Then finishing, the last step. So this last step containing the cleaning of the glasses, grinding of that coming manufactured glass. Then polishing means the surface of that glass must be smooth and safe. Then cutting for the different shapes, and the last one sand blasting. This is the manufacturing method of glass. And next class we are going to discussing about varieties of glasses or different types of glasses. So thank you for watching the video and stay safe your homes.